Hello to the audience behind. Today we're gonna discuss about our first partial project. So first we need to understand the objectives that we said before. So the first one was to understand the concept of odometry and the kinematics of a differential robot. Then when we got this, we implemented and completed odometry of the differential robot using MATLAB and Lego. And then with all of this information, we visualized the robot's trajectory with using MATLAB plotting tools. But the main goal here was to calculate the robot movement and visualize its plot, as is in this case an square trajectory. But first of all, we need to understand what's the most important here, the odometry. Over time, the scientists, engineers have agreed that the odometry is a method that is using computer science to get the data from sensors that comes from all over our environment. And then we transform this data into bits or bytes, and then we compute it, and then we use it in this case, mobile robots. Now it's going to continue my classmate, Milena.
So our robot, the Lego Mindstorm EV3, was configured with specific parameters, such as wheel diameter of 0.042 meters and a wheel axis, that is the distance between the wheels, of 0.175 meters. These measurements are essential for calculating the linear and the angular velocity of the robot. So we implemented the kinematic equations in MATLAB to control the robot's motion. Using these equations, we calculated the position x and y and the orientation theta of the robot at each time step. The robot was programmed to follow a square trajectory with each size measuring 0.4 meters. In theory, the robot should have followed a perfect square path. However, during the experiment, the actual trajectory showed deviations. These were caused by wheel slippage, mechanical inaccuracies, and sensor limitations. So, for instance, while the desired trajectory was a perfect square with equal sides and sharp 90-degree turns, the robot's actual path was slightly irregular, and its scale was much larger than expected. This demonstrates that the impact of calibration errors and the mechanical work.
So through experiments in a controlled environment, we know that odometry is useful, but is limited by various factors, such as a bad measure of the wheels, the distance between the wheels. Also, these can accumulate errors, and the mechanical work can do a significant deviation of the desired trajectory of the road. For the key conclusions, we know that precision and calibration is a crucial factor for the reliability of the dynamic in the real world. For the limitations of the odometry, we can integrate external sensors like LiDAR cameras to improve the deviation of the robot in the real world. This project also have a holistic approach that fusion the software and the hardware. We can add control algorithms to improve the navigation. For recommendations, we can do a continuous maintenance for the robot and the sensors to prevent the deviations and mechanical wear. Integration of another sensors can also improve our project, like the LiDAR 2D, and add different models of or package of navigation. Thank you.